Okay, we're going to start Chapter 3 today, and the good news about Chapter 3 is some of us know how to do this already. We just need to be refreshed. And the bad news about Chapter 3 is that some of us know how to do this already. So Chapter 3 looks like it's going to be fun, I think. All right, here's an example of why we're going to do what we do today. Libby borrowed $450 to start a lawn mowing service. So right away, she's in the hole $450. She charges $35 per lawn that she mows, and she incurs $8 in operating costs per lawn. So you think you're just going out there to mow a lawn and collect $35, when in actuality, what is happening?
She's making 43.
Not really.
Does incur mean subtract or add?
Yeah, she incurs expenses. She's not.
Okay.
Right,
So
she's actually using money to go do that lawn as well, right?
Okay. Yeah.
So what would be some of your expenses if you were mowing a lawn?
Gas.
Gas? What else?
So if your mower broke down?
If your mower broke down, you'd have to get it
String for your
fixed.
weed whip.
Right? String
Oil.
for your weed whip. Oil. Maybe even your transportation to get yourself to that lawn, right? So even though you're charging $35 per lawn, you're not actually making $35 per lawn. And you might not even use $8 in gas, but overall, she's figured out that it costs her about $8 every time she mows a lawn. So what this first line is down here is her actual amount that she gets for mowing a lawn. So if she's down here at one lawn, or at 0 lawns, she's making $0, right? If she mows 4 lawns, if you take 4 times 35, I think you get 140. So she would be up here at 140. And if she mows 8 lawns, she'd be up here at 280. If she mows 12 lawns, she'd be right here. So this is what this line is representing. This line is representing how much money she's making, okay? Her slope, or her rate of change, is very consistent because she goes up 35 every time, right? Okay. This line over here is representing her cost, how much it's costing her to run this business, okay? Before the business even starts, when she's been in business for 0 days, she has already spent $450, right? And every lawn she mows, she spends $8 more. All right? So she's actually increasing this by 8 every step of the way. Her slope is actually 8. Okay? So here we go, and here she is. She's cost, it's costing her this much. So we're really interested in where these 2 lines intersect. Because when those 2 lines intersect,
she's finally paid off her stuff and she can make money.
Right. She hasn't made any money yet, but she hasn't lost any money yet either. She's made what she spent ahead of time, right? This is called her break-even point. This is where things are going to start to turn around for her. Okay? Important, and interestingly enough, a lot of things happen in life where you have 2 linear equations and they meet somewhere. And that meeting point is huge. In business, as in this situation, it's where you start to make money. Okay, that's a good thing. Okay, I think we've talked about this before. Sometimes it could be the difference in a cell phone plan. Okay, which plan is better for you? This plan follows this line, and this plan follows this line. Which plan is better for you? Well, it depends.
The one that starts costing more because
it depends on how much you use your cell phone. You know, it depends. Maybe it's DirecTV and Dish Network. And you want to know, which one's better for me?
Which one's going to be better if I'm going to have it for a month? Or
Right.
Which one's going to be better if I have it for 2
Right.
years?
You have to have, time across here so you know what's going on, If you're only going to watch TV this much time, then obviously this plan is better because it's cheaper, right? But if you're going to watch TV for this much time, then this plan is better because this one's cheaper than that one, right?
Yep.
Okay, so there are a lot of things in life where we're going to talk about needing two things happening at once. And those are called systems of equations. Let me. There are, great. There are 4 ways to solve systems of equations. And I tell you what, we're going to try to learn all 4 today. Okay? And then you're going to pick your favorite. And you can use whichever one you want. I pretty much know what your favorite is going to be already, but we'll see what happens. Okay? The first way you can solve a system is by making a table. And by the way, a system will always be 2 equations at the same time. You usually see them formed with a bracket, or it'll tell you it's a system. Okay? So what they've done here is they've said, okay, here's one of the equations and here's the other one. So I'm going to make an X and Y chart for these. Okay, I'm going to put in 0. You guys got your calculators handy?
Yes.
When you put in 0 in the top equation, what do you get?
8.
Okay.
Yeah.
If you put in 0 to the bottom equation, what do you get?
-7.
Oh, so see, I'm going to actually have a 3-way T-chart here. Everybody followed with me?
Yes.
Okay. So I put in 0, and I got 8 in the first one and -7 in the next one, and I'll get to this in just a minute. Okay? Let's put in 1 in the second one, or in the first one, and you get 6. And if you put in 1 in the second one, you should get -3. All right? Now, what I need to know is, what I'm looking for is I want this number to be the exact same as this number. Because when I find it, then I will know where my lines intersect. All right? But I don't even know if I'm going in the right direction or not. Maybe I should put in some negative numbers here. I don't know. All right? So what you actually do then is you actually take these 2 numbers and you subtract them. So be careful. When you take 8 and subtract -7,
You get 15.
that's like adding, so you get 15. If you take 6 and subtract -3, you actually add them and you get 9. And what I'm looking for is I'm hoping that the difference between the 2 is going to be nothing. Because if there's no difference, then I found the answer. So am I working toward 0 here?
Yes.
I started at 15 and I went to 9, so I'm working toward 0, right?
Yes.
So then they tried 2 because they thought, okay, if I put in 0 and I put in 1 and that was right, then I'll just raise this one by 1. Got these numbers, subtracted them, got 3. Am I still working toward 0?
Yeah.
Yeah. So they went 1 more, got these numbers, subtracted them, and got -3. Am I still working toward
No.
No.
zero? What happened now?
You
Now you went
past.
past.
I went past 0. So the 0 is somewhere in between here, right? So 0 must be somewhere in between here, right? So I know my x value of my solution is somewhere between 2 and 3.
2.5.
I'm not even going to figure it out. They're happy knowing that the answer is between 2 and 3. Okay?
Really?
They're happy right now knowing that. Sometimes you can figure out exactly, and sometimes you can't.
This one would be 2.5, wouldn't it?
Is it?
Yeah.
Yeah.
It works
you-
exactly to be 2.5?
Because when
Yep.
you went up 1, it's
Oh, and
3 on one side of 0 and 3
Oh,
on the
okay.
other side
It
of
could
0.
be. Try it, girls. You put 2.5 in that one, and boys, you put 2.5 in this one, and tell me what you guys get.
I got 3. I got 3 for both of them.
3? Okay, so we found the solution is actually 2.5. I did 2.5 and 3.
Yeah.
The solution is a point. Okay? It's a dot. The solution is a dot.
So then, how do you like if it were to come out to be right at 2,
Mhm.
then for our answer we would write 2, 3.
Whatever, yeah, you got for y.
Okay, so then why don't you have to write a point if you don't know?
You do. If I want, it would tell you if you want an exact solution or not.
Oh, okay.
Okay. It'll tell you. So in this case, the exact solution is 2.5, 3. Okay. What does that mean? Well,
Yeah,
that
that's a
means
break.
if these were lines, it would mean that's where the lines intersect.
Well, if it's exactly at 2.5, then why do you have to have the 3 at the end of it?
Because that's the y point.
Okay.
That's the y. You need an x and a y.
Y.
The other thing that means is this, and a lot of people forget that. That means if you put 2.5 right here, and you do all this math, you'll get 3. Okay? If you put 2.5 right here, and you do all this math, you get 3.
You can substitute.
It's the only point
That works.
that makes both of these true. It seems kind of stupid right now, but I'll show you an equation in just a minute where it's not so stupid. Okay? If it was in standard form, then it would be a little bit easier for you to see why that's so important. But that's the deal for right now. This is called make a table. This is the first way to do this, is to make a table. All right? Now, I'm going to show you why make a table can sometimes be a pain in the butt. Here's a make a table that worked great. They did it for you. It just worked out beautifully. Here were your 2 equations. It's easier to make a XY chart if you put these in slope-intercept form. Okay, so they just rearranged their equation. Do I need to go over that with everybody so you can see what happened there? Shelby? You want to see that?
No, I got it.
You got it? Okay. And then they rearranged this one and just put it into slope-intercept form again. Because that way, if you pick a value for x, you just do all this math and then y is there. Otherwise, if you pick a value for x here, it's kind of hard. Like if you pick 3 for x, that would be 9 plus 2 times what gives you negative 2. Well, that's kind of hard to figure out. Okay? So if you put it in slope-intercept form, it works a little bit better for you. Okay? And so then they just plugged in these numbers, and they plugged in 2, and when they did, they got negative 4 for the first one and negative 4 for the second one, so they knew their answer was 2, negative 4. Now I'll show you why make a table is sometimes a pain in the rear end.
Yeah, if your x is it'd be like 30 or something.
Okay, and I don't know why they did this to us, but they did, so we have to live with it. I actually think this second one is a little bit easier, but let's look at this first one. The first thing we would want to do if we had to make a table is to put this in slope-intercept form. Okay, so we would start out with negative 5y equals negative 2x plus 11. Divide everything by negative 5. And you would end up with y equals 2/5 x minus 11 over 5.
You don't have to put those into decimals.
No, you should not put them into decimals.
Okay.
The other equation ends up being 4y equals 3x minus 13. Divide everything by negative 4. And you get y equals 3/4 x minus 13 over 4. And some of us can already tell why this might be kind of ugly.
Because it's in fractions.
We got fractions, don't we? Oh, I don't like fractions. Okay, but big deal. I'm going to go ahead and start my XY chart. And I'm going to go ahead and start with 0, because 0 is nice. Girls, you're red. Boys,
Negative
you're
11
purple.
over 5.
I need more than one girl to agree.
Negative 11 over 5.
Negative 11 over 5.
Negative 13 over 4.
And boys is negative 13 over 4. Okay, well that didn't really help a lot. What's the difference? Be careful. When you subtract these, what's the difference?
I got 1 and 1.
1 and 1/20.
Yep.
Okay, that'll help us. So let's go ahead and put in, what should I put in there?
1.
1, 2,
2.
2,
1.
1.
Make it 30 times easier.
I don't care. 1?
You're 1/20th away from 0.
1? Okay, what happens if I put in 1 red girls and 1 purple boys?
-4/5.
Double check that.
-1 4/5.
Negative. Double check that, girls.
-1 4/5.
Okay, boys.
-5/2.
Do I hear a second?
Yeah.
Yes? Happy with that? If I subtract these, what do I get? So am I getting closer to 0?
Yes.
Oh, I am. I'm kind of close to 0 right now, aren't I? Let's go to 2. Okay, 2.
How is that closer to 0 than 1/20th?
That's 1 and 1/20.
Oh, 1 and 1/20th.
Okay. So girls put in 2 in the red, boys put in 2 in the purple.
-1 2/5. Yep.
-1.75 or -1.24.
-7/4. Yeah.
-1 3/4.
Yeah, it's the same thing.
Oh man. Okay, what happens if you subtract it?
You get 7/20ths.
Oh my gosh, seriously? 7/20ths?
Yeah.
Well, that's closer to 0, isn't
Let's
it?
go to 3.
Okay, let's try
Yeah, dude,
3.
this is stupid.
Girls, red, boys, purple.
-1.
-1.
Yeah, -1.
-1 for the boys. 2.
Yep.
0.
What's the difference?
Sweet.
0. What did we just find?
The point.
We
Good.
found the answer. The answer is what?
-1.
Good job. The
I'd
answer
like
is
to see those
3.
lines graphed.
Me too.
-1. Believe me, we're gonna get the graphs on this.
Oh,
We're gonna
right.
get
Okay.
Will we get the graph of this one?
Wow. No.
No. We should type this in the Wolfram Alpha.
Wow.
I want to see how close they are
Okay.
the whole time.
So those would have crossed at a nice point for us. That's good. What this means, though, is this. In this case, this means if I put a 3 right here and a -1 right here,
Come on, 0.
it will come out to be 11.
Oh.
This
Yeah.
would come out to be 11. Okay? And if I put a 3 right here and a -1 right here,
It come out to be -13.
this would come out to be -13. It's the one point that makes both of these true. It's the only point that you can put in for both of them and make them both true. Okay?
That's crazy.
So what do you think about this method?
Complicated.
That's a lot of guessing, isn't it?
Yeah.
It's a lot of math.
Couldn't you put 0 in for one of the values?
I did put 0 in for x. Right there.
Oh, never mind.
I did. It didn't make it any easier, did it? Okay? I'm not going to do this one because it ends up being even uglier, but you get the idea of how to make a table. Correct?
Yeah.
Okay. Very good. Luckily, we don't make tables too often.